Earthlings! Welcome to the new adventure of the Earth Scientastic Journey. I am Teacher Delves, your Earth Science enthusiast. Today we will explore another mystery of science, the fascinating and exciting journey of index fossils. So, buckle up, dear explorers, as we set forth to unravel the mysteries that surround us on this extraordinary scientastic adventure. After going through to this lesson, you are expected to do the following. Define what is index fossils or guide fossils. Identify how index fossils are used to describe subdivisions of geologic timescale. And finally, explain why it is rare for an organism to be preserved as a fossil. Before we proceed with our lesson, answer the following questions.
Question number 1. Fossils can include imprints of leaves and footprints. What are these types of fossils called? A. Trace fossils. B. Bone fossils. C. Shell fossils. Or letter D. Mineral fossils. What is your answer? Good job! It's letter A, trace fossils. Question number 2. An archaeologist finds a fossilized human footprint in a rock layer with evidence of ancient plants. What is the most likely interpretation? A. The plant and human existed at different times. B. The human footprint is a recent addition to the rock. C. Humans coexisted with these ancient plants? Or letter D, the footprint is a hoax. What is your answer from this question? The correct answer is letter C. Humans coexisted with these ancient plants. Question number 3. When a dinosaur bone is buried in sediment and exposed to mineral-rich fluids, what happens during the petrification process? A. The bone decays completely. B. Minerals turn it into stone. C. The bone turns into a different type of rock. Or letter D. The bone remains unchanged. What do you think is the correct answer from this question? You're acing it. It's letter B. Minerals turn it into stone. Question number 4. You are an archaeologist exploring a prehistoric site, and you've discovered a fossilized dinosaur footprint. Which of the following best describes the formation of a mold and cast in this scenario? A. The footprint is filled with sediment by forming a cast, and the surrounding rock hardens to create a mold. B. Minerals replace the organic material of the footprint, creating a cast, and the impression left in the sediment forms a mold. C. Microorganisms consume the soft tissues of the footprint, leaving behind an empty space as the cast, and the surrounding rock becomes the mold. D. The footprint is preserved as a cast, with the original impression left by the dinosaur forming a mold in the sediment. Do you think you got this right this time? What is your answer? Very good, it's letter B. Minerals replace the organic material of the footprint, creating a cast, and the impression left in the sediment forms a mold. Question number 5. A group of paleontologists has discovered a collection of insects perfectly preserved in amber. What does this finding suggest about the insect? Statement 1. They were likely preserved through the rarest forms of fossilization. Statement 2. Their soft body parts are most likely decayed. Statement 3. They were trapped and preserved in fossilized tree resin. Statement 4. The amber contains no relevant information about the insect. A. 1 and 2, B. 1 and 3, C. 1, 2, and 4, or letter D. 1, 2, and 3. What is your answer from this question? Very good, it's letter B. 1 and 3.
Do you recall the last time you collected souvenirs during a vacation or from an exciting event? Those might have included pictures of fascinating locations or the companions you shared those moments with. Fossils bear a striking resemblance to these souvenirs, but they hold a distinct role as time capsules from the distant past. Essentially, they serve as nature's tangible representation of the creatures that once inhabited our planet. Similar to how your souvenirs evoke cherished memories, fossils provide a glimpse into the bygone world before our time. These fossils aid researchers in reconstructing the intricate history that unfolded millions of years ago. Join us on this journey as we delve into the fascinating world of fossils and discover the remarkable stories they tell. Unearthing Earth's memories, one fossil at a time. So let's begin by defining fossils. The word fossil comes from the Latin word fossus, meaning dug up. Fossils are the preserved remains or traces of once living organisms from the past. They provide us with invaluable insights into the Earth's history and the processes that they have shaped it. Fossils can take various forms, such as bones, teeth, shells, imprints of leaves, footprints, and even some unusual things like barrows and coprolites, which are fossilized feces. The key is that they provide us with a snapshot of life in bygone eras. Now, let's dive into the different types of fossils. There are four main categories. Number 1, petrification. Petrification is the common method of fossilization. It happens through a process called permineralization. When an organism's remains such as shell, bone, or tooth is buried in sediment, mineral-rich fluids penetrate the material, replacing organic matter with minerals like calcium carbonate or silica. Over time, the original organic material turns into stone or becomes petrified. Number 2, compression. Some fossils are formed when the remains are compressed under high pressure by overlying sediments or water. This pressure creates a dark imprint of the fossil. Number 3, molds and cast. In some cases, the original shell or bone dissolved away, leaving behind a space or mold. Later, sediments can fill this space to create a matching cast. Soft-bodied sea creatures are often found as molds and casts because their shells dissolve easily. And finally, number 4, preserved remains. The rarest form of fossilization involves the preservation of original skeletons and soft body parts. For example, insect shrouds and perfectly preserved in amber, which is fossilized tree resin. Now, let's discuss index fossils, also known as guide fossils or indicator fossils. Index fossils are incredibly important in understanding the relative ages of rocks and fossils. Index fossils have 4 key characteristics. Number 1, distinct and unique. They have distinct features that make them easy to identify. Number 2, widespread. They are found all over the earth, making them useful for correlation. Number 3, abundant. A large number of these fossils can be found in the rock layers. And finally, number 4, short-lived. They existed for a relative brief period in the Earth's history. Index fossils are incredibly useful for correlating rocks. By identifying these fossils in different rock layers, we can determine the relative ages of those rocks. This allows us to create a timeline of Earth's history and place various rock layers in order from oldest to youngest.
Did you know that we have an ammonite fossils in the Philippines? One of the sites where we discovered this include the Silungan ng Gigante in San Andres, Catanduanes. These fossils from Catanduanes are estimated to be Aptian Albian age. Though extinct, ammonite shells serve as an index fossils to help our geologists date and identify the age of other fossils and rock formations. The fossils discovered in Catanduanes underscores the importance of preserving geological and paleontological heritage. Protecting these natural treasures ensures that future generations can continue to learn from them and advance our understanding of the Earth's history.
And that, my friends, concludes our lesson on fossils and index fossils. Fossils are a window into the past, and index fossils are like the keys to unlocking Earth's ancient history. They help geologists piece together the incredible story of our planet. We have just covered some important information in today's lesson. Now, it's time to assess your understanding of this topic by answering the comprehension questions.
An index fossils are found in a layer of rock in Montana and a similar fossil in a rock layer in Texas. What can you infer about the age of fossils? A. The fossil in Montana and Texas are the same age. B. The fossils in Montana are older than the fossils in Texas. C. The fossils in Texas are older than the fossils in Montana. Or letter D. The age of the fossils cannot be determined from this information. What is your answer? Good job! It's letter A. The fossils in Montana and Texas are the same age. Question number 2. You are conducting a global study of fossils and find the same fossil species in various continents. What can you conclude about this species? A. It's probably not a fossil but a modern species. B. It's a unique and isolated discovery. C. It's likely to be widespread and found all over Earth. D. It's a species that only existed in one specific region. What is your answer from this question? Very good, it's letter C. It's likely to be a widespread and found all over Earth. Question number 3. Which of the following serve as bases in identifying index fossils? A. An organism must have lived during a long period of time. B. The fossils of the organisms are at least abundant on Earth. C. The fossils must be found in a limited area on Earth. Or letter D. The organism is unique and easy to identify. What do you think is the best answer? Well done! The answer is letter D. The organism is unique and easy to identify. For question number 4. Fossils are essential in understanding the history of life on Earth. Which of the following statements best explains why this is the case? Statement 1. Fossils provide direct evidence of past life forms and their evolution. Statement 2. Fossils can reveal information about ancient climates and environments. Statement 3. Fossils are often found in igneous rocks which are resistant to weathering and erosion. A. 1 and 2, B. 2 and 3, C. 1 and 3, or letter D. 1, 2, and 3. What is your answer? Absolutely correct. It's letter A, 1 and 2. Question number 5. A paleontologist discovers a fossil that has a distinctive and unique appearance, but it's found in only one small region and lived for a long time on Earth. Is this fossil a good candidate for an index fossil? Statement 1. Yes, because it has a unique appearance. Statement 2. No, because it has a limited geographical distribution. Statement 3. Yes, because it is distinctive in appearance. Statement 4. No, because it lived for a long geological time span. A. 1 and 3, B. 1 and 4, C. 2 and 3, or letter D. 2 and 4. What is your answer? Well done. It's letter D, 2 and 4.
Thank you for participating in our scientific adventure. Join us again for another exciting exploration. I am Teacher Delves, your earth science enthusiast, saying, index fossils are the keys to unlocking the secrets of the past. Until next time, keep exploring and keep learning about the wonders of our planet. See you and goodbye!